Good day, everyone. You're welcome to class. In this class, we'll be looking at a question under resistor in series and in parallel. Okay, so the question says an electric circuit is connected up as shown below. What is the value of the current through the 1 ohm resistor? So we are looking for the current flowing through this 1 ohm resistor. So let's try to find the direction of the current. Now, this is a 12-volt cell connected. This is a negative terminal and this is a positive terminal. That simply means the current flows in this direction, meaning this is the current that we are looking at. But here we are looking at series and parallel connection of resistors. If we say resistors are connected in series, we are saying the same current flows through them. But if they are connected in parallel, there is shared current. Now, if you look at this 1 ohm resistor, when it gets to this particular junction, or we call it node, the current will share into this way and this way. Now, looking at this particular current that is flowing here and here, the same current flows into these two, and this same current flows into these two. So let's quickly state how to resolve for series connection. The total resistance in series is just to add them straight, R1, R2, and so on and so forth. But for parallel connection, we have 1 over R total is equals to 1 over R1 plus 1 over R2, and so on and so forth. So that's what we'll be doing. So for to take care of this, I will be erasing it just as we are solving. So we said this and this are in series. So by the time we resolve these two, we will get 3 plus 3, and that will be 6. So that simply means I will be erasing this part, meaning I have resolved this and turning this to 6 ohms. That simply means I have resolved these two resistors. Likewise, these two resistors are also in series. So let's say I am erasing this part and then making this one to become 6. Now, looking at this, we have this 6 ohms and this 6 ohms in parallel. Now, having 6 ohms, 6 ohms in parallel, let's put it into here. So we have 1 over that, we have 1 over 6 plus 1 over 6. Now, if you take the LCM, that is 6, we have 1 plus 1, and that gives us 2 over 6. But because it is the inverse, that means the total resistance will give us 6 over 2, and that is 3 ohms. Actually, one of the secrets to this is once you have two same resistors of the same resistance, if you are resolving them in parallel, you will actually get half of one of them. So now, because of what we have done, I can also now erase this, then erase this, because what I have done is to parallel the line. Now I have a 3 ohm resistor in series now with the 1 ohm resistor. Now we have this and this in series. So if we are solving that, we have the total resistance now in series. That's 3 plus 1, and that gives us 4 ohms. Now, according to the Ohm's law, we have our voltage as 12. V equals IR. We are looking for I. I is equals to V over R. And that is what? 12 divided by 4. Our current flowing through there is equal to 3 ampere. 3 amps. So that's the current flowing through the 1 ohm resistor. Till we meet next time, keep studying.